how's all this stuff get here? There's a lot of stuff out there, but it comes from somewhere. And so this talk is going to kind of touch on a lot of that. And you'll see at least a few references to the Apple Watch, not because I'm a particular fan of it, but because it's visible. And I think it touches on a few of these things pretty nicely. So uh, there'll be other examples as well, but mostly this is just kind of going through some of that process. For some background, I spent 11 years managing a product development team for a contract manufacturer across a broad array of industries. But then now I am product managing software development, but specifically for manufacturing. So a little bit of background on kind of the behind the scenes work on how some of these things start to exist. Several different kind of aspects to this. We'll do a little introduction, talk about product life cycle, resources, talk about the idea stage and how some of these concepts start percolating, looking at design steps, the actually creation of whatever it is, the use of it, disposal, and iteration. A lot of this stuff isn't particularly linear, but kind of broken it down into these little subcategories so we can uh, start to understand some of the concepts, but also try to highlight where some of these things might interact, or you may go backwards and forwards or hop around in some of these aspects. The product life cycle. So life cycle management is a very broad discipline. There are tons of different subcomponents to it. There are a lot of different approaches that you can take to it. A lot of different techniques people use, a lot of different strategies, and each of the subdisciplines all kind of roll up. There's different expectations for product managers today, people who are kind of taking care of this overall plan. And the idea that a lot of people have at the moment is that they should be experts in all the things. And some of them are better than others at each individual aspect, but it's not just one person. Like there are many, many people involved in this. Even when it's a single person who's trying to launch their own little pet project or product, there's usually somebody else involved. And so it's not just an individual thing. There's a ton of communication aspects to all of these steps. But overall, starting from idea, going into design, going into the actual making of it, the use of it, disposal, and then future iteration. Uh, the resources required. Uh, these are things that are going to appear across all of those different aspects. At each stage, you need funding. There's going to be some kind of monetary input, and that's going to have a huge influence over what actually happens. So you'll see each of these four kind of recurring as I'm going through, and I'll try to highlight where some of them maybe have more influence than others. The knowledge. Uh, if you want to publish a book and you don't know anything about printing, then that's going to be a challenge if you're going to be the one who wants to print it. So you may have to find somebody else who knows about the printing portion. If you don't know how to do the layout, you may need to find somebody else who understands how to do the layout. There's tons of these kind of knowledge aspects to it. There's also a skill aspect. It's not just what you understand, it's what you're able to execute. And some of these skills are going to be knowledge-based skills, but some of them are going to be interpersonal skills. Some of them are going to be physical skills. If you're trying to put something together and you don't have the manual dexterity to be able to put the screw in at the right angle without stripping it, that's going to be a challenge. And another big one is equipment. And this one has a huge impact when you start talking about kind of mass manufacturing of things or doing things at larger scales. Because the equipment is going to dictate a lot of aspects, but especially it's going to impact the cost. So starting with in the idea category, starting with demand, if there isn't a desire, if nobody wants things to change, they don't change. Like somebody has to want something different. Somebody has to say, you know what? I would like this new thing. I would like this different thing. And that can be specific to one individual person. Like one person can say, I really want a watch, but I want it to connect to my phone. And maybe that's just one person. Maybe that's the only person that wants that. Or maybe there's a large group of people and they didn't necessarily know about each other, but as soon as they start talking about it and getting some visibility out there, then that starts, collecting a lot more support, a lot more interest, enthusiasm. Uh, but without that desire to begin with, uh, the products don't happen. Things don't just come out of nowhere. They start with some kind of desire. And money at this stage uh, doesn't have to be a major driver. Some of these things can be done just in a very kind of bootstrappy kind of way, where you don't have to have the final version that's nice and polished. You can start playing around with something that's fairly simple, and I'll kind of touch on that a little bit more in a moment here. Um, but knowledge becomes particularly important. You have to understand what the thing is, have to understand the space a little bit more. Uh, Tooling is not necessarily that important, the equipment, and skills can be important depending on what you're trying to do. But just understanding what that desire is and helping like really solidify that in your mind is a big first step. And sometimes for an individual, that's easy to do. Sometimes it's hard. But a lot of these things come from, especially at large scales, come from this huge kind of market research that people are doing. They're looking across the signals that people are sending out by what they buy. So from there, you need to look at a concept. So I had the picture of the Pebble Watch before as part of the desire, because that was an independent product that went out and uh, got a lot of attention. It was one of the first Kickstarters or may have been the first to hit $1 million, and it showed a lot of demand that a lot of companies didn't really see was out there. And then you have this independent person come out and generate a lot of excitement and demand around a concept. But even that concept wasn't new. Uh, that concept existed as, as far back, at least, as Dick Tracy and the Dick Tracy watch. I remember watching the Dick Tracy movie as a kid and seeing that watch and just being overwhelmed by how cool this was and how much I wanted it. And it was 20 years later before I saw one on the market that actually kind of started to capture some of that idea. So the concept may be around for a long time, but it doesn't necessarily mean that it's going to exist as a product. And so uh, getting that idea out there is an important first step, but it's not enough by itself. Uh, and you maybe look at the Dick Tracy watch and look at some of the features and say, oh, it has all those things now. Like I go buy a watch now and it has all those same kind of features, but that's not necessarily where you're going to end up. Like there's significant differences between what happened then and what is available now. And a lot of it comes down to changing understanding of the knowledge out there, the tools and equipment and the skills that people have. So the next step is kind of looking at requirements. one of the things that I'm a big fan of trying to do when I'm working with customers, trying to understand what they want, is clearly separating out requirements and desirements. A lot of people have a lot of desirements. They want something real bad, but it doesn't necessarily match with what they need for their product. And so I like to try to tease out the two of those and really kind of nail down what are the true core requirements. What has to happen in order for this thing to be viable or what they're looking for. And so I use, because I'm referencing the Apple Watch here, used an iPod. Uh, and maybe the concept is I want an iPod, but I want it strapped to my wrist. It can keep track of time, right? It works a lot like a watch, but it has additional features. It has some music storage, and you can add other potential applications or functionality to it. In a lot of ways, this covers the core of what a watch is. Okay. Uh, what more do you need? What are the specific requirements that you need in order to make this the watch that you're looking for? Maybe you just start with an iPod and you get some Velcro and strap it to your wrist. And in a lot of ways, that's what Apple did. One of the, like a lot of the work that was being done originally involved taking an iPhone and some Velcro and strapping it to a wrist because the hardware development was extremely complex and there are a lot of different components to it and a lot of different work. And iterating on hardware is much slower than iterating on software. And so they were making software adjustments and working on some of that using a phone strapped to a wrist rather than working on a watch directly. And so there's uh, just because you want it to be a watch doesn't mean it has to be a watch while you're refining this concept. And so one of the things that I highlight here is as soon as you start translating your concept into design requirements, your concept will start to change. The idea starts to shift. Okay, the Dick Tracy watch, super cool, and it had this big speaker on it so you could talk to each other. But the technology today is different. The use case is a little bit different. People listening to this are more likely to use like Bluetooth and they're more likely to have headphones. They don't need a big fat speaker dominating the space of this watch. There are other aspects that are more important. Maybe the screen is more important. There's a touch screen. Why is there a touch screen? Well, someone decided that was a requirement for the watch in these days, but it wasn't something that even existed. It wasn't even a concept in the days of the Dick Tracy watch. So this shifts pretty significantly as you start refining and applying that knowledge and applying skills and having understanding of how the equipment that you have factors into this. The next component is thinking about the R&D. Research and development can be a lot of different things. I worked on a part that uh, was a user interface for a breast pump. And so they wanted something new and modern and exciting. And so they wanted it to be touch sensitive, but they wanted it to be capacitive touch. They had color requirements that they wanted. They wanted the touch area to look this nice uniform color, but when it was started up, there would be icons that would appear that weren't visible before. They had cost requirements that made it so that they had some other challenges, and they had this aesthetic that they were shooting for that no one had done. This was new, and it was mostly in a new in a plastic molding kind of way. They wanted to mold plastics in kind of a different order in order to achieve the specific aesthetic that they were looking for. No one had done that. No one even knew if it would work. So one of the things that we do is we look at where are the risks in a design. And one of the risks in this design was, is this plastic mold going to work at all? We have no idea. So how can we mitigate that risk? How can we address that? We can say, okay, I'm going to do a little experiment. I'm going to take this different mold, different product, but kind of a similar shape, and I'm going to try it in this order with this other plastic in between and see what happens. And maybe it works, maybe it doesn't. But I can start with that, and then I can see where the next problems are, where the next challenges are. And maybe we're going to try it again with a little bit different layout. Maybe we'll try it again with a little different plastics. Maybe we find out that the inks that are being used to give us this kind of graphic appearance don't work with that heat. And so they have to change those in order to get it to work. So there's a lot of this kind of exploratory work that happens. And that's for one small aspect. If that works, then maybe you get this aesthetic that you were looking for. If it doesn't work, you may have to come back and revise your concept. You may have to try again. And this is one of those areas where money can be a big factor. Uh, the capacitive touch for the iPhone in particular was an incredible expense. The amount of money, the amount of engineering hours, the number of people, the number of companies around the world involved was gigantic. But it worked. And so then other companies see this thing that works. They're like, oh yeah, touchscreens. It works. It's great. We love it. It feels great. We want that too. But they're not necessarily willing to spend the money to make that thing happen. And that makes a big difference in your ability to get some of these new technologies, get some of these new things out there. Sometimes you have to go with something that's a little bit simpler, a little bit cheaper, something that's more established, more of a commodity. And so you'll see some of these design decisions get adjusted based on the current technology that's available and how expensive it is to realize for your specific product. Next, we're going to talk about validation. Validation happens at a lot of different stages. Uh, you can have a design validation where you look at this idea and maybe you've built a 3D model in a computer and you're thinking about okay, how's this going to fit on a wrist? Is this going to work well on my wrist? And so you model in an arm and you model in somebody else's arm, you model in a few different arms, and you stick that watch onto those arms in the computer model and you look at it and you say, okay, it looks like this will work. Or, oh, on this wrist, that looks really bad. It's just too big. Maybe we can make it a little bit smaller. And so you can do some of these kind of initial validations as just kind of a design uh, perspective. You can do validations for things like uh, checking against requirements. If you have a requirement that this watch work in the snow, then you need to understand how does the snow impact it? Does the temperature change the function of the circuit board or of the touch screen? Uh, by the way, it does. That's an important consideration. Does moisture change if it's snowing and you get moisture on your touch screen? Does that change the sensitivity? Yes, it does. How do you correct for that? How can you account for that? Um, and so some of these things are easier to imagine, and you can do that evaluation. Other things may be a little bit of a surprise. Maybe if you happen to have thought about it before, you would have recognized that it was going to be a challenge, but maybe it's something that you didn't even think of. Maybe you find that you do your initial validation and the touchscreen works just fine. You don't have any issues, but when it's on a wrist, you're getting some kind of interference from your skin on the back side of the watch compared to the skin on the top side of the watch as you're trying to make those adjustments. I don't know that this was necessarily an issue with the Apple Watch, but that is the kind of issue that you might see with a capacitive touch application. So these are things that may just appear and you're not clear, but as much as possible, you want to try to validate some of these designs as early as possible so you don't spend a huge amount of money on something that won't work or has some other challenges, or paying for equipment, building things that would be required that maybe then need to be adjusted later. So there's a lot of opportunity in the validation step to save money and resources if you do it well. But it can be very hard to do because you have to imagine lots of different things that could fail, and sometimes that's hard to imagine. Another thing, and this one's kind of related to that validation step, but it's also related to kind of these next steps on the making side of things, and that's prototyping. So again, we're kind of using the Apple Watch as an example, and I'm using this kind of physical aspect of it to begin with, but the same thinking applies to software, non-physical products. Uh, but one of the things that people do is they build a prototype. They put something together and just kind of see how it goes because there's a big difference between the concept on a computer and actually having something in your hand that you can use and touch and feel, look at. And so they serve a lot of different purposes. You can have prototypes that have nothing to do with your future manufacturing process. There are entire companies that will go out and they will take a machine and they will create one or two or 10 of something from scratch in an extraordinarily expensive way that no one would be willing to pay for, as an end user. Uh, some of these initial prototypes, you might think like an Apple Watch, maybe it's $500. It might be $10,000 if you're making one of them. And so these are used for a very specific kind of purpose. And it's usually something like trying to understand if you're going in the right direction before you spend a whole bunch of money on equipment, tooling, that kind of thing. But another big aspect that it's used for is just getting alignment from different stakeholders. So for a large company, if you're making a product, there's going to be some kind of committee, some kind of group that says if they want to continue funding your product, your thing. And you may have a large group that looks at it and says, okay, we'll give you $200,000 to get a concept out there, uh, and figure out if that makes sense. And you build a prototype, you show it to us, and we'll decide if we want to give you more money. And so you spend that $200,000, you get this concept, you hand them the prototype, and they look at it, and they touch things, and they feel it, and they say, uh, "Ooh, we don't like this. We like this." A lot of different things that they want to see differently, but they also say, "Yes, we'll go on to the next step. We will fund the $10 million that's required for the next step in this process." And those numbers vary significantly depending on what you're trying to make. For consumer electronics products like that, that's not an unreasonable kind of starting point for the expense. For your if you're making a hand carved back scratcher, you're probably not going through $200,000 just to get a concept out there. You don't need $2 million for machining to get something going. But it depends very much on what you're making. But that's just kind of a illustrative for this. Uh, Prototypes can be significantly different as far as their level of sophistication. Uh, the iPhone strapped to a wrist with Velcro demoing software is a prototype. That's useful. It tells you some things, but it doesn't tell you others. A non-functional watch that just has the shape and weight and all of that figured out is useful for other considerations. So you adapt your prototype based on the thing that you're trying to explore and understand. And I put prototyping last because it's kind of it's intimately related to design, but it's also related to the making of something. And when you're making something, you start with a plan. You don't just go out to a tool and start cutting pieces. You you can start this plan at various different stages. You can start it from the very beginning concept, but you can also consider it, much later in the process, and you'll always want to keep revisiting this plan, refining it. Maybe you find, there's a technology shift, and you're able to manufacture something a little bit differently. It saves a lot of money, and so you want to adjust your plan to accommodate that. A big one, and this one is huge on the money aspect, is tooling. Uh, so this is a plastic mold. So for injection molded plastics, uh, there's a lot of different types of tooling out there. It's not necessarily, physical tooling. This can be tooling for software, the infrastructure required, cloud systems, all of that. So there's like tooling is just kind of this broad category, but tooling is about creating the thing or getting the thing out there without being the thing itself. So you're not selling the tool. You are selling the thing that the tool helps produce. And so in this case, a tool might be extraordinarily expensive. Like maybe you're trying to make plastic parts and your tool might be $20,000 for your tool. You're trying to sell your plastic part for 5 cents each. How does that work? Plastic itself is fairly expensive. The tool is very expensive. How are you selling it for 5 cents each? And a lot of it comes down to the tool allows you to make a lot of things in a repeated way very quickly, and you save a lot on labor because labor is extremely expensive. And so by doing plastic molding, and you'll see molds that like this is a one-up mold. It's molding one thing at a time, but you'll see molds that'll have 20 identical things in one shot. So they'll inject the plastic into the mold and they'll pop it out, and you get 20 copies very, very quickly. And that's where some of those savings come from. You can have temporary tooling where somebody just takes a mill and they carve it out of plastic, or you can have more permanent ones where, like this one, where it's carved out of metal. They different tolerances, different aspects of that, but it is a huge consideration. And if your tooling is bad, you're going to have a hard time having a successful product. Another consideration is the supply chain. Uh, you need stuff to make your thing. You need something. And from the raw materials to huge assemblies, if you look at an airplane, each of those components of the airplane may be a complete thing that someone else sells and ships elsewhere, and then that gets put together by another company. Or it may be that you need ore that then you're going to refine into an ingot and sell to somebody else. There's a huge variety of stages in this, but it's all about getting the things that you need to make your thing where you need them to make it and in a state that you can actually use them to make your thing. And so there's a lot of planning, there's a lot of expertise. This is a huge knowledge area for people who are trying to
Mark, your audio cut out.
Mark, we can't hear you.
I'm a f Yeah, there we go. I don't think he can hear us either. If his headset battery died or something. Hello? Hello?
can you hear me?
Yep, now we can hear you.
Sorry.
We lost about
Yeah.
2 minutes there.
Okay. We'll start over on this build slide.
Yeah.
So this build, uh, you need to get your components together And maybe that's raw materials, uh, maybe that's different subcomponents that are kind of coming together as a final assembly. But there's a transformation component. I have a picture of some Foxconn workers here because they do a lot of iPhone and Apple Watch assembly. You may have robotic lines, so you may have big assembly lines often seen in car manufacturing, but there are much smaller versions that are available that get used for other components. So it's kind of a broad spectrum there. But you have to actually make your thing. And again, I'm kind of emphasizing the physical products here, but this applies very readily to software or other products as well. Testing. This is also kind of tightly related to validation, but you need to make sure that your thing does what you want it to do. You don't have to do this. You can ship things without testing it, but especially in kind of larger volume things, uh, errors will come out and that will degrade a lot of trust and that will cause a lot of problems, potentially lawsuits. Uh, Testing is important. One example where this kind of backfired was Intel back in the day uh, did not do complete full truth table checking of their processors. And it was discovered that for an extraordinarily remote number of instances, it would do the calculation wrong. And maybe that's not a big deal because it's extremely rare. It doesn't happen very often at all, except a processor does calculations a lot very quickly. So maybe one processor doesn't have a problem, but you start distributing thousands and thousands of them, and they're all doing millions and millions of calculations, and some of those calculations end up being wrong. That can make your processor fail and make people very unhappy and can cause a company like AMD to come in and say, no, we've done full truth table testing. And all of a sudden they become a huge competitor when before they weren't. So testing is important. You should definitely think about your testing plan. Distribution. We talk about desire driving change, but also you have to get your thing to the people who want it, whether that's by shipping, trucks, flights, downloading, whatever your distribution method. You need to sell it. You need to build excitement. If no one uses your thing, what does it matter? And so one of the things that the Apple Watch did was kind of leverage that kind of Apple sales system and generate a lot of excitement that allowed it to become a dominant watch out in the marketplace. Maintenance. If your thing fails, can it be fixed? That can be an important consideration. If it's extremely expensive, people are more likely to want to fix it rather than just throw it away and buy a new one. So the maintenance considerations are important, and that can be external services, external people with knowledge or skills related to it, or it can be something that you offer as part of your product. Coming into disposal, can you recycle it? Is it something you can reuse? Is it something that you can transform into something else? Uh, Recycling is a major consideration for a lot of sustainability initiatives that companies have. And then alternatively, maybe you just discard it. Maybe you throw it away. I have a very small plug here. I'm a fan of the idea of trying to incorporate the cost of the full disposal of something into the upfront costs so that we're not just buying something because it's cheap, even if it's expensive to throw away later, because that cost is invisible to us. The kind of disposable plastic usage that we have has generated tons of waste, tons of challenges, tons of problems, and that cost comes back later, and we pay it. Everyone pays that cost, but it's invisible at the beginning when we're first buying that product. And if we were able to bring better visibility into what the total cost was, then that would influence our buying decisions and maybe shift the way that we approach some of these products. So that's something that I don't have a good solution for, but it's definitely something that I think about. Iteration. Do it again. You made it. It exists. It's a thing, but you have an idea to do it better. You have an idea to do it differently, cheaper, faster, whatever it may be. And you can see there have been a lot of different iterations on the Apple Watch. There are a lot of different iterations on everything that we produce potentially. But this isn't just the product itself. It also applies to all of the previous steps. You might iterate your tooling. You might iterate your design concept. You might iterate your supply chain. There are a lot of different things that you can look at. Iteration has actually become a kind of a core component of software development, where instead of iterating on the product itself, you iterate on aspects of it and you start from one small component, iterate, 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 iterate until that final thing becomes a kind of demarked product, but you're still continually developing it, continually adjusting it. And so that has also led to some shifts in some of the funding models where you're not just paying a whole bunch of money up front for a thing and it's yours forever. That has helped spur some subscription models as well, where people are constantly paying a monthly fee and theoretically the product is continuing to develop and be refined and shift over time. But there are a lot of different components here. I know that there's a lot of a lot of content going through some of these things, but I just kind of wanted to give this general overview of how things come to be, going from this design, the idea, these design concepts, how you're making the design, how you're actually making the thing, uh, looking at the kind of tooling or testing and touching on sales use and it's just some of these general processes. Thank you.